Houston flight entity.
NTD Houston flight.
Perform BFS pre-flight oblique loading.
Copy, put it one.
That's Nancy one.
The NASA test director has asked Houston flight to send their pre-flight uplink command to the orbiter's backup flight system. These are loads sent from Houston via the Mila tracking station and put the 5th general purpose computer in the proper configuration. Pilot Bryon Duffy is in the process of performing the main propulsion system helium system configuration. This will open the helium isolation valves necessary for the in-flight purges of the engines and provide an emergency source of pressure for pneumatic shutdown of the engines. The water levels in the water spray boilers are receiving a final checkout and being verified to be sufficient for the mission, and the helium system of the main propulsion system is now being configured for launch. So at this point, final check is being made of all of the orbiter's consumable systems. Just a few minutes, the booster test conductor will be asked to start the gaseous nitrogen purge of the aft skirts. The flow of inert gas ensures that no explosive or flammable gases can accumulate in the bottom of the solid rocket boosters prior to ignition. And at this point, all non-essential personnel are being cleared out from the launch pad danger area back to the fallback area. And we're awaiting a report that the fuel cell purge is complete and that any adjustments are being made in that purge. At T-minus 13 minutes, 55 seconds and counting, this is shuttle launch control.
COOS. Go ahead, OOS. Holmes STS cross-seat valves are configured for flight. All steps performed. Copy.
OTC PLT, Holmes interconnect is complete.
Copy 958 CNTC.
Copy.
PLT OTC, would you please perform the MPS helium reconfiguration?
Roger, it's in work. OTC PLT MPS helium reconfiguration is complete.
Copy that, PLT. OTC CFCP. Go ahead. Your fuel cell purge is complete, and we're ready for fuel cell load adjust. Copy 992. EPD, CFCP, CECL, adjust fuel cell loads to between 250 and 290 amps. EPD copy. ECL copies.
NTD STM.
Go ahead, STM.
1010 complete.
Copy. TMQCF 994, it's complete.
Copy.
Countdown clock will hold at T-minus 9 minutes and 2 minutes and 50 seconds. CVFS OTC.
Go ahead.
Can you give me 1003? Stop and compare.
Stand by. OTC CVFS.
Go.
Step 1003 is complete.
Copy. Attention on that all systems, discontinue all non-mandatory LDB traffic for remainder of count. CDR OTC.
Go ahead, OTC.
I understand you had a concern on the horizontal set config.
Okay, we were waiting for the weather update updates, and we think the questions will be answered. We had runway 15 was already on the horizontal sit, and we were pre-briefed it'll be 33, but we'll wait for the weather updates.
I copy that. We'll give you that with the weather update.
Oh, CCME.
Go ahead, CCME.
10-7 complete, 10-08, not performed.
This is shuttle launch control at T-minus 9 minutes, 30 seconds and counting. We're about half a minute away from going into the final built-in hold, and as soon as we do that, we'll receive the final poll from the payloads community as to their readiness to support the launch this morning. Launch Director Ed Priselic advises that there are some clouds offshore and some showers to the northeast, but none that would affect us here directly. 3, 2, 1, T-minus 9 minutes and holding for 10 minutes. Standing by now for a final go from payloads.
This is Payload Director. I'd like to do the final poll now prior to launch. Tom Brakefield, KSC Payload Operations.
Yeah, John, we polled the payload management team in firing room 2 in the C1 console, and the Atlas and mid-deck payloads are ready to go.
Okay, Dean Hunter.
Go ahead, PD.
Dean Hunter, Atlas Experiments.
Atlas Experiments will go.
Emmett Crook, Space Lab Systems.
Yes, John, Space Lab's ready to go.
Okay, this is the final poll. Appreciate your readiness to launch. You'll go to PTC Direct if there's a problem from here on in the count. Thank you.
The final word from the payloads community that they're ready to support.
Let's runway to KSC 33 and select close aim point if there are no deltas.
Stand by 1 second. We're getting a new aim point for you.
This hold has about 8 minutes and 40 seconds remaining in it. When the countdown resumes, the ground launch sequencer will be in control of the countdown. The ground launch sequencer is a master computer program issuing all the commands to perform the final critical task to put the Space Shuttle Atlantis in its launch configuration. During that 9 minutes, the ground launch sequencer will poll and monitor as many as 1,000 different parameters on the Space Shuttle to make sure that they are not falling out of any predetermined limits, or red lines as the launch team calls them. All personnel in the firing room are switching over to the same communications channel and will be staying on that channel through launch. At this time, the weather is go from the Space Shuttle Launch Director.
Yes, is go. Mala?
Milo, go.
STM?
STM, go.
Safety console? Safety's go. SP? SP, go. CDR?
We are go.
LRD? LRD is go. And SRO?
SRO is go. You have a range clear to launch.
Copy. Houston flight NTD.
NTD Houston flight.
Yeah, you go for launch?
Stand by 1 second. I'm not go at this time.
chairman of the mission management team, Brewster Shaw, is now polling the mission management team of their readiness to support. All members of the MMT reporting their go.
CMQC 1026 through 1028 not performed.
Copy.
1029, 1030 not performed.
Copy.
Brewster Shaw, the chairman of the mission management team, has completed his poll of all of the members of the team. Everyone reports they are go and ready for launch. And that word being passed now to Space Shuttle Launch Director Bob Seek.
Can I get a CMQC on 145 in preparation for recorder start? CMQC 145.
Copy.
We still have
Yeah, I can give you 1034 and not performed for 1031, 32, and 33. Very good, thank you.
5 minutes remaining in this built-in hold. At this point, we don't see anything significant. It's apparent that would preclude us from launching here in about another 13 minutes.
For weather at this time, we're working a potential 4,000 deck at KSC. I do have some data for the crew that I'd like to pass on runway information.
You got to go.
Okay, a word there that Houston Flight wants to assess a 4,000-foot deck of clouds in the area.
Atlantis, Houston, Charlie, I've got the weather data for you. Zaragoza is currently observed go and forecast go. It'll be our tail site. That's close aim point, nominal speed break.
Okay, John, we copy Zaragoza, nominal speed break, close aim point.
That's good copy. KSC 33 will be our RTLS runway. That's close aim point, nominal speed break. And right now we are no go. We're looking at a potential 4,000-foot broken deck, and we'll advise you.
We copy.
NTD Launch Director.
Go ahead.
Okay, while we're waiting on a final confirmation from the weather aircraft, I'll conduct the management poll at this time.
All right.
Payload Operations Director.
Payloads are go, Bob.
Copy. Engineering Director.
Engineering is go, Bob.
Copy. Safety and Quality Director.
Safety and quality is go, Bob.
Copy. And Cape Weather.
Launch Director, we have no weather launch constraints violated. Steady state wind forecast for launch from 010 degrees at 16 knots, over.
Copy, thank you.
ISL RPS NTD. This is ISL. This is the RPS. 1035, activate recorders. The RPS copies. ISL copies.
Coming up 2 minutes now remaining in this hold. The weather reconnaissance aircraft is making an approach to the shuttle landing facility and is assessing that 4,000-foot broken cloud deck.
We're complete. We can give you step 1053.
Copy.
Ops Manager, Launch Director, 212.
Go ahead, Bob.
Okay, Brewster, while we're waiting on the final weather confirmation, is the management team go to proceed?
That's affirmative.
Copy, thank you, sir.
And Launch Director, we're ready to proceed with the exception of flight and weather.
Copy.
OTC, H-Wedging.
Go ahead.
Yeah, we need to brief the crew on the number 2 APU ready to start talkback. It is expected that the number 2 boiler steam vent temperature will decrease below 130 degrees, and we'll lose the number 2 boiler.
You have 1 minute from resume. I understand.
If this condition occurs, ignore the lack of the APU ready to start talkback and proceed with normal APU start.
You copy CDR?
We copy that.
And Houston flight entity.
NTD Houston flight?
There, you go or no go?
I am no go.
GLS cancel pending.
GLS copy, that's complete.
Okay, launch team, we're going to extend the 9-minute hold. We're no go for RTLS weather.
And that's the run being made by pilot Steve Nagel. We are extending this hold now, pending that evaluation.
Roger. ISL, our recorder's activated.
NTD ISL, we've been holding off until we get a go for launch.
Activate the recorder's ISL.
Woke up.
Weather is always the wild card in any launch attempt, and that is the reason that we continually run an astronaut in the shuttle training aircraft to assess the conditions in real time, what he's actually seeing on approach, because obviously if the crew has to turn around and come back, they have to have a straight line of sight to the runway below 8,000 feet. And we also have to assure that there is no precipitation or clouds with any electrical potential within the flight path of the vehicle. So we're now at T-minus 9 minutes and holding.
Start our count inside of 9.
Okay, how long do you think it's going to be before we'll ever...
We're trying to clear a couple of items at Zaragoza, mainly the PAPIs, and we're trying to confirm our KSC reports. Right now he's also having a viz problem with the navs.
All right.
We're working both.
Okay, ISL copy.
ISL copies.
NTD C-Power. Go C-Power. Yes, sir. If we're going to be in an extended hold here, we'd like to reapply power to the igniter heaters. Let's stand by for a few minutes, C-Power, unless you're getting critical on that. Negative. Watch it and keep us advised. Copy.
NTD CECL.
Go ahead, ACL.
Yes, sir. If we're going to be in an extended hold, we may need to have the fuel cells bring back the load to conserve water for tank A.
Okay, let's sit this way for a few minutes, ECL, unless you get into a problem. Copy that. We don't have any estimate on the hold at this point.
I copy.
But we could be ready to pick up here momentarily.
This is His Highness Crown Prince Philippe of Belgium, who is here obviously to witness the launch of Dirk Frimout, the payload specialist on this flight. We're extending the T-9 built-in hold to address some concerns by Houston flight. From a Cape standpoint, we are ready to support in firing room 3.
One, please. APU 161. APU.
APU copies.
We're at T-minus 9 minutes, still holding, no estimate.
DCL entity. Go ahead. How do you look on water? At our present rate, we'll hit the LCC upper limit in 102 minutes. Okay.
NTD SRO on 212.
Go ahead, SRO.
Due to the length of this extension of the hold, the range has to rescind its final clear launch.
What do you need to do?
Well, we'll need a couple of minutes prior to resuming count to repole our people.
Go ahead and repole them now.
Okay, I understand. We will be picking up here shortly.
We need to be ready to go on a moment's notice, so repole them.
Roger.
We're awaiting the assessment from the weather reconnaissance aircraft, the shuttle training aircraft, of the cloud and visibility conditions at the shuttle landing facility.
What's your status?
No go at this time until I get a final from range safety.
You have an estimate?
Very shortly.
When the hole is extended, then the various systems have to repoll their lead people to be sure that all systems are remaining green and that they can pick up on very short notice. So that's what's going on. This is the shuttle landing facility, and the clouds that are there are being assessed for their visibility from the end of the runway as to whether or not there is any precipitation within those clouds and whether or not the commander would have a straight shot, a straight view toward the runway should he have to turn around and come back. And as we have seen on a number of occasions, even though our launch weathers go at the pad, we may not have quite acceptable conditions at the shuttle landing facility. The one item of discussion today, which really has not amounted to much, is the crosswind factor at the shuttle landing facility, which has remained within tolerance. We're still in the T-minus 9-minute built-in hold. As you can see there, the windsock is pointing pretty much at a right angle across the runway, and of course that's one of the concerns, but the velocity has been below our requirement, which is 15 knots, so we're go on the crosswind issue. Still awaiting a final word from pilot Steve Nagel.
Blast, they're evaluating the latest data. All
copy. Launch director. Launch director, NTD.
NTD Houston flight?
Go ahead, flight.
Yeah, I have just cleared the weather at both Zaragoza and KSC. I believe we'd have a good approach at KSC regardless of the weather in 40 minutes. At least one end of the runway would be good.
Copy. Are you go?
I am go at this time.
Understand. SRO, NTD.
SRO.
We're go except for you.
Roger, copy. I'll get back with you as soon as I can.
NTD Houston flight?
Go ahead, flight.
I need to give you one other piece of information that the Zaragoza weather probably will not hold in all that long, so...
Understand.
NTD SRO and 212.
Go ahead, SRO.
Okay, range is go. You have a clear to launch.
Understand. Launch director, NTD.
And there's our clear.
NTD, you have a go to proceed.
Understand. ISL RPS, start recorders. ISL copy. RPS copy. Okay, launch team, we're going to pick up the count momentarily. GLS, pick up the count on your mark.
3, 2, 1, mark.
And we're T-minus 9 minutes and counting. Ground launch sequencer now controlling. Ground launch sequencer relays commands to the onboard computers, which report back then that those commands have been executed.
And OTC, that's complete.
Copy.
The primary job of the onboard computers, which we'll switch to after 31 seconds.
Go ahead, Phil. Recorders are activated. Copy.
The onboard computers are called the Redundant Set Launch Sequencer, or RSLS, and they make the final checks that all of the Space Shuttle launch vehicle systems are met and ready to go. So, in other words, the Space Shuttle in that last half minute is checking itself. Getting ready for retracting now the orbiter access arm, which the crew uses for access. In an emergency, that can be moved back in around the orbiter in about 15 seconds if that's necessary. Next event will come at 6 minutes when the orbiter test conductor will give pilot Bryon Duffy a go to perform the auxiliary power unit pre-start procedure. He'll set the switches in the cockpit to put the APUs in the ready to start configuration, which...
This CRPF. Start the recorders by the clock. CRPF copy.
The APUs start at 5 minutes. That's the last critical point at which we can hold if we need to at T-minus 5 minutes and be able to sit there for any duration of time.
TLP OTC.
Go ahead, OTC.
Perform APU pre-start.
T-minus 6 minutes and counting.
APU pre-starts in work. And OTC PLT pre-start's complete. We've got 2 gray talkbacks and 1 barber pole as expected on number 2.
Copy that. APUs copy.
And Duffy reporting the configuration of those auxiliary power units. Those APUs will be given a command to start at T-minus 5 minutes in about 20 seconds. Orbiter flight recorders as reported are operating. T-minus 5.
TLS go for orbiter APU start.
TLP OTC.
Go ahead, OTC.
At this time, perform APU start.
Roger, APU start in work.
And pilot.
Go ahead, OTC.
Would you reconfigure heaters, please?
That's in work.
Charlie Bolden being asked to reconfigure the orbiter heaters for launch. Pilot Bryon Duffy is flipping 3 switches in the cockpit to start each of the APUs, and he'll report when that activation is complete.
OTC PLT APU start is complete. 3 good ones, and the heaters are reconfigured.
OTC copy.
Hydrazine now flowing from the tanks toward the APUs. Stand by for final range safety checks.
TLS go for bird sequence 4.
Final check now of the orbiter's flight control elements. Standing by for gimbaling the 3 main engines. Rudder elevons and speed brakes all have moved through a program test pattern, and they are verified ready to go. T-minus 3 minutes, standing by to gimbal the main engines. The main engines are now in the start position.
So for ET, LO2 pressurization.
Starting now to pressurize the liquid oxygen tank on the external tank. Atlantis now on internal power. Atlantis being powered by its onboard fuel cells.
PLPOTC.
Retraction of the gaseous oxygen vent hood now underway.
No unexpected errors.
Roger, that's in work.
Pilot Bryon Duffy reports that the action to clear the caution and warning memory system is now in work. He'll be reporting back.
The caution and warning's clear, no new messages.
That action reporting complete. No surprises there.
Close and lock your visors. And
Go ahead, OTC.
Flow. Good luck and Godspeed, Atlantis.
All right, thank you guys very much. We're
Let's go for ETLH2 pressurization.
Replenishment of liquid oxygen to the external tank is now being terminated.
1 minute 30 seconds.
At T-minus 31 seconds, we'll have the handoff from the ground launch sequencer to Atlantis' onboard computers. The Space Shuttle has now been disconnected from all ground propellant loading systems. T-minus 1 minute and counting. Ground launch sequencer verifying that the main engines are ready for ignition. The heaters around the joints of the solid rocket boosters are being turned off. Residual hydrogen burn igniters have now been armed. They'll be fired at T-minus 10 seconds to burn off any residual hydrogen under the main engine nozzles. Sound suppression water system is being armed. T-minus 35, standing by for the handoff. T-minus 31, the handoff is complete. Onboard Atlantis computers now controlling. Booster hydraulic units have been started and a final steering check of the engine nozzles is underway. T-minus 20. Body flap and speed brake in the launch condition. Sound suppression water system activated. T-minus 10, 9, 8. We're go for main engine start. 6, 5. Main engine start. 3, 2, 1. And liftoff of the Space Shuttle Atlantis on a mission to planet Earth.
Houston, Atlantis, in the roll.
Roger, roll, Atlantis.
Houston now controlling. Atlantis is rolling to the proper up-down position for its climb to a 57-degree inclination, 160 nautical mile high orbit. Three engines now throttling down as Atlantis prepares to pass the air of maximum aerodynamic pressure. Atlantis speed now 500 miles an hour, downrange 1 nautical mile, altitude 13,600 feet. One minute since liftoff, altitude now 33,000 feet, downrange 3 nautical miles, Atlantis now traveling 1,023 miles an hour.
Atlantis, Houston, go at throttle up.
Roger, John, go ahead, throttle up.
3 engines now throttled back up to 104% of rated capacity and operating well. Good hydraulic systems, good electrical systems. Altitude 68,000 feet, downrange 8 nautical miles. Atlantis now traveling 1,705 miles an hour. One minute 50 seconds since liftoff. Atlantis now traveling 2,386 miles an hour. Flight controller standing by for burnout and separation of the solid rocket motors.
Atlantis, 2 engine Zaragoza.
Copy, John. 2 engine Zaragoza. Good SRB SEP. Good stable Team Ecos.
And Atlantis, we copy. Performance nominal.
Copy. Nominal performance.
Those calls indicate that Atlantis' first stage performance with the solid rockets was as planned, and that Atlantis could now perform a landing at Zaragoza, Spain on only 2 engines if that were to become necessary. However, 3 engines still operating well at 104%. Altitude 225,000 feet, downrange 54 nautical miles. Atlantis traveling 3,400 miles an hour. Time since liftoff, 3 minutes. Three engines continuing to operate well at 104%. Good hydraulic systems, good electrical systems. Altitude 300,000 feet, downrange 98 nautical miles. Atlantis now traveling 4,430 miles an hour. Time now liftoff plus 4 minutes.
Atlantis, negative return and press to ATO.
We copy, John. Press to ATO and negative return.
Those calls indicate that Atlantis has gained too much altitude and is traveling too fast to return to the Kennedy Space Center if that were to become necessary, and also that Atlantis could press to a lower than planned but safe orbit on only 2 engines if that were to become necessary. However, all 3 engines continue to operate well at 104%. Good hydraulic systems, good electrical system. Altitude now 351,000 feet. Downrange 174 nautical miles. Atlantis now traveling 5,800 miles an hour.
Atlantis, press to MECO.
Copy, Houston, press to MECO.
That call indicates that Atlantis could press to a normal main engine cutoff with only 2 engines operating if that were to become necessary. Time since liftoff now 5 minutes 10 seconds. Altitude 364,000 feet, downrange 219 nautical miles. Atlantis now traveling 6,818 miles an hour.
Atlantis, Troop Zaragoza 109.
We copy, Troop Zaragoza 109, John.
2 minutes 50 seconds to main engine cutoff. That call indicates that Atlantis could perform a transatlantic landing at Zaragoza, Spain on only 1 engine by throttling that engine up to 109% if that were to become necessary. However, all 3 engines continue to operate well at 104% of capacity. Good hydraulic systems, good electrical systems. Altitude now 370,000 feet.
Atlantis, single engine Zaragoza 104.
Copy, single engine 104.
That call indicates that Atlantis could reach Zaragoza on only 1 engine by leaving that engine at 104% if that were to become necessary. However, all three continue to operate well. Good hydraulics, good electrical systems. Altitude 368,000 feet, downrange 353 nautical miles. Atlantis now traveling 9,545 miles an hour. Now 2 minutes away from main engine cutoff.
Atlantis single engine press 104.
We copy single engine press 104.
That call indicating that Atlantis could reach a normal main engine cutoff on only one engine if that were to become necessary. However, all three continue to operate well. Altitude 364,000 feet. Atlantis now traveling 11,250 miles an hour. Downrange 450 nautical miles. Good hydraulics, good electrical systems. One minute to main engine cutoff, three engines throttling back as the vehicle passes through an area to limit the amount of stress on it to 3 times the force of gravity. Altitude 360,000 feet, downrange 585 nautical miles. Atlantis traveling 14,318 miles an hour. "20 seconds to main engine cutoff. Atlantis now traveling 15,680 miles an hour, downrange 677 nautical miles, altitude 365,000 feet. Flight controllers now standing by for shutoff of the main engines. Booster officer confirms the normal shutoff of the main engines. Controllers now standing by for jettison of the external fuel tank from Atlantis.
Houston, Atlantis.
Roger, Atlantis. We see nominal MECO, no ohms 1 required.
Okay, the pride of the fleet concurs.
Booster officer confirms a good separation of the external tank.
Atlantis, Houston. Charlie, you have a go for the photo DTO.
Okay, we copy, John. We'll put that in work.
That call indicating that Atlantis crew members will photograph the external tank as it separates from Atlantis.
Atlantis, Houston. Com check on Tidris East.
We got you loud and clear, John. How else?
You're loud and clear, Charlie.
This is Mission Control. Houston, We will be leaving live coverage of the Atlantis mission for playbacks of the launch of Atlantis from the Kennedy Space Center. We're 25 minutes and 30 seconds away from ignition of an orbital maneuvering system burn that will put Atlantis into a circular 160 nautical mile high orbit. All systems on board Atlantis are continuing to function well with a flawless ascent to orbit. Atlantis currently passing over Central Europe.
Atlantis, Houston, you have a go for APU shutdown on time.
Okay, John, we just had the body flap light get out, and we'll go ahead and put it in work.
Roger that.
Go ahead, Marshal Commentator. This is Houston Commentator.
Atlantis, Houston.
Go ahead, John.
Charlie, you have a go for vacuum inerting anytime after MET of 18 minutes. Nominal ohms to targets, and preliminary TIG is 37:03.
Okay, we copy. Go for vacuum inerting, and Bryan's already got his clock going. Nominal ohms to targets. Houston, Atlantis.
Go ahead, Atlantis.
Yeah, John, just want to give you a heads up. I'm going to go ahead and press on with the MPS power down and vacuum and early.
Okay, you have a go for that. Atlantis for Charlie, we need Pry Fess on, Pry A on.
Okay, John, that's complete.
This is Mission Control, Houston on board Atlantis. Commander Charlie Bolden and the crew of STS-45 continue to ready the spacecraft for its stay on orbit and for an upcoming engine firing that will circularize Atlantis' orbit at approximately 160 nautical miles. Atlantis' current altitude is 119 nautical miles as it continues to increase in a highly elliptical orbit, and it reaches a high point in that orbit of about 153 nautical miles altitude. The orbital maneuvering system engines will be fired to circularize the orbit. Currently about 14 minutes and 45 seconds away from ignition of that engine firing. That firing of the orbital maneuvering system engines will last for approximately 2 minutes and 31 seconds and result in a change in velocity for the spacecraft of 255.5 feet per second, or about 171 miles an hour. Again, this firing of Atlantis' orbital maneuvering system engines will last 2 minutes 31 seconds and result in a change of velocity for Atlantis of about 172 miles an hour. Circularizing Atlantis' orbit at 160 nautical miles.
Yeah, right here. You're right here.
Atlantis, Houston.
Atlantis, Houston.
Hot mic.
Okay, John, thanks.
And Atlantis, I've got an updated TIG for you, 36:20.
Okay, John, we copy.
Atlantis, after your ohms burn, that'll leave you with an orbit of 160 by 152. We'll probably need to burn later on to circularize that.
Houston, Atlantis, John, we got the ET doors closed and latch. Good indications, and the times appeared good.
Okay, we see that. We concur. Atlantis, Houston, with a switch throw on A12.
Okay, John, stand by one. Okay, we're ready for it.
Okay, you're about to get an alarm SM thermal message. So back on A12, need APU heater, tank, fuel line, water sys, 1 Bravo, 2 Bravo, 3 Bravo to auto.
And all three are complete, John.
Thank you much.
This is Mission Control, Houston. We're now about 7.5 minutes away from ignition. Correction, about 8.5 minutes away from ignition of an orbital reading system engine firing for Atlantis. that will circularize the spacecraft's orbit to an orbit of 160 nautical miles high by 153 nautical miles high. Following that engine firing, very slight engine firing will be required later in the flight to circularize Atlantis' orbit at 160 nautical miles, per the requirements of the Atmospheric Laboratory for Applications in Science. At main engine cutoff, Atlantis' velocity was about 4 miles an hour less than had been predicted. Atlantis currently is traveling at about 17,500 miles an hour. However, for all intents and purposes, Atlantis' climb to orbit was completely normal. Atlantis is about 5.5 minutes away from passing out of range and of communications and out of range of the Eastern Tracking Satellite. We'll lose communications with Atlantis for a few minutes before regaining communications with Atlantis through a ground tracking station in the Indian Ocean. And we will be out of communications with Atlantis for ignition of the oil maneuvering system engine burn. However, shortly after shutoff of the OMS engines, we will regain communications with Atlantis.
Go ahead, Atlantis.
Yeah, John, be advised, we're getting just constant white noise on UHF.
Okay, we copy that. Atlantis, Houston, we're going to lose you over the hill in about 2 minutes. We'll pick you up S-band at Diego at about 38 MET.
Okay, we copy, John. And we're 2.5 minutes from the burn.
Roger, you have a go for the burn.